Hello and welcome to another Senior Curriculum Inspiration proudly sponsored by Texas Instruments Australia. The Curriculum Inspiration series is designed to help teachers to develop strategies in the effective use of Texas Instruments calculators and software in the mathematics classroom with carefully selected and pedagogically sound mathematical activities. My name is Peter Flynn and I'll be your presenter for this session. Today we'll be focusing on the activity titled Pythagoras 3D, and I'll be showcasing the Texas Instruments CX-CAS platform. And kudos for this activity goes to Neil Woods, who developed it. And one of its strengths is it introduces students to quite a few of TI-nspire applications, which I'll briefly mention in the next few minutes. All the files for today's activity can be downloaded as shown on the top right of the screen. The components of the activity consist of a student's worksheet, teacher notes, and also an accompanying TNS or TI-nspire file. The thrust of this particular lesson is that students are provided with a TNS or a TI-nspire file that includes an interactive diagram of a three-dimensional box. And each side or edge of the box can be varied with the subsequent diagonal lengths displayed. And if I take you back to the previous slide, you can see there we've got our three-dimensional box, we've got length, width and height. And you'll also note there that on the screen you have sliders that you click on, and that allows you to change the dimensions of the box. And what happens is you get an immediate update on the screen with regards to the length of that diagonal, which you get in exact form and also in floating point decimal form. And so students are to compute the length of the diagonal to verify Pythagoras' theorem in 3 dimensions. So I don't have enough time to run through all of the activity, but after students are encouraged to calculate that diagonal for various box dimensions using the calculator application, students are invited to, as you can see on the screen here, to use the list and spreadsheet application to calculate the diagonal. Now, the nice thing about this activity is that in columns A, B, and C, you can define the dimensions as variables. So in column A, length, in column B, width, and in column C, height. And you can insert some values for the various lengths, widths and heights there, as you can see. And then in column D, you can introduce a variable called diagonal. And if you look there in cell D1, a cell formula has been entered, and it's the square root of A1 squared plus B1 squared plus C1 squared. And this is a nice part of the activity where the students are asked to, or can be asked to develop a formula which will calculate the length of the diagonal in that spreadsheet environment. Note also in that spreadsheet application that in the first row, the diagonal is expressed in exact form, and in the second row, as the length, the width, and the height are in floating point decimal form, it therefore occurs that the diagonal appears in floating point decimal form. So the form of the input plays a large role in the form of the output. And so I think that this is a very nice introduction to the list and spreadsheet application in the guise of studying Pythagoras' theorem in 3 dimensions. And the task then goes on to get students to complete that table below for various lengths, widths and heights or the dimensions of the three-dimensional box. And you can also ask the students to express the length of the diagonal correct to 2 decimal places, which forms good practice for when they have to do that in their Year 12 examinations. You know, sometimes they're asked to put their answer into a particular form. So I can see this being very, very useful, you know, even at Year 10 with a view forward to Year 11 and Year 12. The task then goes on to introduce the least well-known but I think most powerful application of the TI-nspire suite of applications, and that's the notes application. So repeated calculations which are occurring in this task can be performed in a calculator page, which I'm not showing today but is part of the task, but can also be done in the notes application. And I just wanted to spend just 3 or 4 minutes just stepping you through how that is done. So once you get the hang of this, then hopefully you'll see the benefits for the power of the notes application for performing repeated calculations, which you can save, and students down the track in their Year 12 exams can use these note pages to answer exam questions accurately and efficiently. So students will read this and they'll follow the instructions, and the teacher can, you've got a choice as a teacher to talk the instructions through with the students, or you can just get them to see if they can follow the instructions themselves. It's up to you. But to insert a notes page, there are a number of ways of doing it. Control I is one possibility, where the I stands for insert, and then you can select add notes. And what that does is it brings up the notes page, and as the notes page suggests, you can insert text. And so what's been written there in that first cropped screenshot is the phrase first side. In other words, we're going to assign the first side of the right-angled triangle. And the very important mathematical object that forms the basis for the notes page is an object called a math box, or a mathematical expression box. And that's the object within you do the calculations. So it says there in that top section, you enter the text for the name of the first side, and then what you would do is you would press menu, insert, and then math box. There is a shortcut for inserting a math box as well, and that's Control M to insert a math box. And as you can see there in that top cropped screenshot, you've got the phrase first side, and you've got a math box that's open. Now, what Neil has done here is he's typed in the value 6, and then he has pressed Control var, var being short for variable, and he's used the store command. So he's storing A, one of the side lengths, to be 6, just an arbitrary value. You can also use the assign command, which is :equals, and that's also on your keypad. They both work the same way. I think for Year 10s, storing is fine, and storing, you know, would make you know, quite perfect sense to them, I think. Then what you see there in the second cropped screenshot, so we've got a value 6. It's been stored as variable A, and then you press enter to finish the calculation. It's very important. So in that second crop screenshot, the blue is the input and the green is the output. Now, when you're performing repeated calculations, my advice would be is to show the input and the output all the time. In a moment's time, I'll show you how you can change the appearance of a math box. So what Neil's done there, if you look at the third crop screenshot there, is repeated the situation, inserted a second side with 8 stored for the variable B, make sure that the text is written on the main screen and that the 8 stored as B is written in the math box. So get your cursor and you navigate around the screen. It becomes apparent when you're inside a math box and when you're not. Okay, so when you're inside a math box, the boundary of it lights up, if you like, with a dashed or dotted border, and so you can see that you're definitely in the math box. So what Neil's done there, if we go to the top cropped screenshot, is we've got a first side, we've got a second side, and then the text hypotenuse has been added, and then a formula's been added, the square root of a squared plus b squared, and then enter has been pressed to calculate the length of the diagonal. So you can see there that this is a 6, 8, 10 right angle triangle. And what you can then do is you can go up to the first side and the second side, and this is what's shown in the second crop screenshot, is you can change 6 to 4.5 and 8 to 5.3, and you get an automatic update for the length of the hypotenuse, which in this instance is 6.95. Now, if you place your cursor in any math box that you want to change the appearance of, if you then press Menu, Math Box Options, and then choose Math Box Attributes, you can then choose to either show input and output, to hide input, to hide output, or no calculation. And as I said, my feeling for repeated calculations is always to show the input and the output. And when you go to change a value or change something that's in a math box, always press Enter to complete that particular operation. So this screen also basically shows what I've been talking about. In a math box there, the command round has been used, and you can also see that hypotenuse, the square root of a squared plus b squared, has been stored as a new variable c. In other words, c squared equals a squared plus b squared. And to get students actually to try and think this through is pedagogically a very nice activity as well, rather than just telling them. You'll also notice that there's a round feature, and so it's saying take your value for variable c and round it to 2 decimal places. The comma 2 denotes that, and so the length of that diagonal, or the length of the hypotenuse there, to 2 decimal places is 6.88. And so I've skipped a little bit more of the task. The students are then asked that Pythagoras' theorem is generally applied to triangles in 2 dimensions. Explain why the theorem can be easily adapted by adding a third side to calculate diagonals in 3 dimensions. And so you can either work through this with the students, or the students can show it themselves, is that the new hypotenuse becomes the square root of L squared plus W squared plus H squared. Then there's some work on Pythagorean triples, which I have not shown you here, but it's the idea of verifying that 8, 15, 17 is a Pythagorean triple, 20, 21, 29 is a Pythagorean triple. There are also sets of 4 numbers that are called Pythagorean quadruples, and they're sets of 4 integers that adhere to the Pythagorean 3D formula. And 2 such members are mentioned here before question 7, namely 3, 4, 12, 13 and 5, 12, 84, 85. And students can use the listen spreadsheets application on page 1.6 of this file, or the notes page that's been, you can get students to create a notes page that will help them answer this question, to enter the first 3 values of each of the above sets to verify that the 4th value is an integer, and then get students to experiment to see if they can find any other Pythagorean quadruples. So as you can see there in blue with the sets of quadruples in red, you can see that 6, 8, 24, 26 is one, and that's one because it's a multiple of 3, 4, 12, 13. Now, that's okay if students find multiples of existing ones. That's no problems. But you can also ask students, and this is a very, very nice extension and really lovely way to finish the activity, is to ask students to determine a systematic approach for finding Pythagorean quadruples and to provide an example of your method. And so give students a bit of think time. You may have to give them a hint, but, you know, to concentrate on, well, where have you seen 3, 4 before? Where have you seen 12, 13 before in relation to the triples? So given a set of Pythagorean triples, look for another set where one of the values is part of another Pythagorean triple. For example, the sets of Pythagorean triples 3, 4, 5 and 5, 12, 13 both contain the value 5. So that 5 is an anchor value. And the union of those two sets is 3, 4, 12, 13, which is a Pythagorean quadruple. So, you know, appealing and to the more talented members of your class there who really enjoy, you know, working with numbers and enjoy, you know, working on basic number theory. So I hope you've gained some useful ideas that can be used in your classroom to inspire your students from this curriculum inspiration session. That's all we have time for today, so please visit the Texas Instruments Australia website for more free activity lessons that make students explore or encourage students to explore, discover and visualise mathematics in innovative and dynamic ways through using the Texas Instruments technologies. And for when the next curriculum inspiration is scheduled, until then, thanks very much for watching, and it's goodbye for now. Cheerio.